Okay, good morning, guys, in this group. Uh, my name is Ibrahim Mohammed. I'm trying to solve this question that this man sent in the forum. I don't know whether it was question 1C, something like that. I'm trying to solve it. Which the question is saying a particle moving in a straight line with uniform acceleration has a velocity of 40 meters per second at point P, 20 meters per second at point Q, and comes to rest at a point R, where QR is equal to 50 meters. The question that is asked now, we are asked to calculate Roma 1, the distance PQ, and Roma 2, the time take to cover PQ as well. Now, this is the question that we are asked to solve. Now let's try solution to solve the question. Now already we have had from the question saying a particle we are moving in a straight line with uniform acceleration has a velocity of 40 meters per second. Before ever we collect any data, we have to represent this information in a rough diagram. Yeah, please, we have to represent the information on a rough diagram. So that is, if we make something like this one, a line moving, because we are seeing a particle moving in a straight line with uniform acceleration. Now this is a straight line that this particular particle is moving. They are saying what velocity of 40 meters per second at a point P. Now let's represent here. This is point P. Here is point P. So this is P. It is what 40 meters per second. 40 meters per second. 20 meters per second at a point Q. Let's say here is point Q. Here is point Q. Point Q is here. That is 20 meters per second. Now finally it comes to rest at what point P? Yeah, R. Sorry. Here is point R. But point R we don't know. And we are going to know. How are we going to know? Let's represent it at 0 meters per second. It is what 0 meters per second because it has come to rest. There is no force acting on it again, so it doesn't have any velocity. So its velocity that having is what 0. Now, by going further, we have already had that, and the question is given where QR is equal to what 20 meters per second. That is what QR. This distance here, the distance from this point to here, the distance from this point to here is what 50 meters. 50 meters. Very good. Now, from this particular problem, we should now look what we are to do. In the question we are asked to find the distance PQ. This distance PQ we are asked to find. Before ever we find this distance, there is some things that we have to look at. In this particular problem. Now let me write all the equation of motion that we are required to use in this particular question. Which one that we are to use? We have V is equals to U plus AT, and we have S is equals to UT plus half AT square, and we have V square is equals to U square plus 2AS, as well as we have S is equals to V plus U upon 2 all multiplied by 3. From these four equations, which one that we are to use? Now, a particle moving in a straight line with uniform acceleration has a velocity. Now, in this particular question, Acceleration is included because they are saying with uniform acceleration has a velocity of 40 meters per second at a point P. But acceleration is not given in this question. How are we going to try to solve acceleration? Now, if you look at this particular diagram that we have just get, by looking at this what question at these formulas, we are to use this particular formula. S is equals to ET plus half AT squared to find what no. We have to use this one. V square is equal to U square plus 2AS, because if you take this one, this is not given, time is not given, and as well as if we take this one, time is not given. If we take this one, time is not given as well. But if we take this one now, we have to find what we are need. We have to look at for acceleration. So the equation that we are going to use here is what? V square is equal to U square plus 2AS. So u here is equal to what? We are going to take this one as our u. That is what? The initial velocity that was taken from what? From Q to R. So that is u is equal to 20 meters per second. And as well as we are going to take our v as what? 0, because it was the time that the particle finally comes to rest. So we have to represent v is equals to what? 0 meter per second. And the distance, that is what? S is given. S is equals to what? 50 meter. And our A is not given in the question, which we are going to look out for. So from this equation, we have to substitute S. V is now be equal to what? V is equal to 0 square, which is equal to U is equal to 20 square plus 2 into A. The S here is what? 50. Also, very good. So this implies now saying this, understanding. So this implies now saying this is what? 0 is equals to what? 400. 20 square is 400 plus 2A into 50. Also, so 0 is now be equals to 40 plus what? 5. 2 times this one is what? 100 A. So by taking this one to come across the equal to sign, it become minus 400 is equal to 100 A. So divide here by 100, divide here by 100. So this will cancel. A is equal to what? Minus 4 meter per second square. So this is our acceleration. Now, by going further now we are now coming to our question that we are asked to calculate. We are now going to calculate what? The distance from this point to this point. Now, from this particular equation that we have derived here, or we are written, we have already seen this equation. It is the same equation that we are going to use again. V square is equal to U square plus 2AS. So that is what? V square is equal to U square plus 2AS. Also, very good. Now let's correct our data again. Now in this particular point, from P to Q, we know the initial velocity was what? 40 meters per second. So here now U is equal to 40 meters per second, and what? Final velocity is 20. V is equal to 20 meters per second. I don't want you to ask me a question. Why are we taking here initial velocity and final velocity, and we are taking this one as what? Initial velocity, when we are looking out for what? Acceleration. The reason being is we are told in the question that this particle was moved in a straight line with uniform acceleration. It was having a velocity of 40 meters per second at a point Q. That was the initial velocity when the particle moved at a point from this P. 20 meters per second at a point Q. Now if you are moving if you are moving a straight line, now you have moved. Let's take this one as an example. You have moved from this point. Here is K school. Now you are coming to Islamic, from there finally to Ahmadiyya, something like this. You are moving from K school to Islamic, finally to Ahmadiyya. Now when you move from K school here, your initial velocity is what? 40. You will now come to Islamic. You will come to Islamic now with this other velocity. Finally, where you are yearning to go, that is Ahmadiyya. Finally you have reached that. When you come to Ahmadiyya, you no longer has any other side that you are going to continue your journey to. So if that be a case, your velocity to where you are reached is what? 0, because no other external force is acting on you to move again. So if that be a case, your final velocity is 0. So that is the reason. If we are walking around this distance from Islamic to what? Ahmadiyya, you are moving. You are starting the journey from Islamic to Ahmadiyya. So your initial velocity must be 20 from Islamic here to Ahmadiyya. So please, that is the reason why we operate here. 0 as final velocity, 20 as initial velocity. Now we are moving from K school to Islamic. So that is the reason our initial velocity from K school is 40. That is U is equals to 40. And our final velocity is what? 20. That is our V is equals to 20. Now we have calculated our acceleration A, which is equals to what? Minus 40 meter per second square. So what next again? S, which is what? The distance that we are now looking for is equal to question mark. We don't know. Now so from this equation now we can substitute. That is V is equals to what? 20 is equals to U is equals to now what? 40 plus 2 into minus 4s. So this is what? Square. Sorry, yeah. So 20 square is what? 400 and 400 is equal to 20 square is 400. Now 40 square is what? Is it what? Let me get with my calculator. 40 square is what? 1600 minus 2 times 4, 8 minus 8s. So this is equal to what? Let's take this one to come across the equal to sign. So that is 400 minus 1600, which is equal to minus 8s. So 1600 minus 400 which give us what? 1200 minus or equal to minus 8s. So we divide it by minus what? Here is minus because the bigger number carry the sign. So we divide here by minus 8. So minus 8 cancels. So s is equal to what? 1200 divided by 8 will give us what? 150 meter. So this is what? The distance. It was the distance what? PQ, which is equal to 1150 meter. Now Roman 2, we have to calculate the time take to cover PQ. Now we are now calculating the time taking to cover PQ. From this particular equation that we wrote, we know that the first equation that we have took, that is what? V square is equal to U square plus 2as. We don't have time there. So if that be a case, we have to look in the equation again which one that we are going to take to find our what? To find our what time. Now if we take this one, we don't have either. No, so we are not, in fact the simplest equation that we have to take this particular question is for solve this particular question is what v is equals to u plus 80. So that is v is equals to u plus 80. We know our v from this point here, v is 20, which is equals to u is 40 plus into minus 4, which is our a, times what the t that we are looking for. So this one should come here again. So 20 minus 40, which is equals to minus 4t. This is minus, please. So this is what 20 minus 20. 20 minus 40 is minus 20, which is equals to minus 40. So divided by minus 4, here by minus 4. So minus 4 cancel. So t here is now be equal to what? 5 seconds. So the time taken to cover PQ is equal to 5 seconds. So thank you so much. Actually I'm not at home, but when I return back at home, I'll try to look at the question. Presently, guys, I'm at village, but I'm coming today at Kenema. So I think guys are studying hard. So please, ladies and gentlemen in the group, let us be taking our work very hard. These are things that we are expecting to be doing. Let us be helping each other whenever someone has problem. Please. Yeah. Thank you very much. I am Ibrahim Mohammed.